In this third video, we will show you how the rotary motion of an electric actuator motor is turned into the multi-turn, quarter-turn, or linear stroke required to operate a valve. The first type of valve stroke is multi-turn. In this case, the motor is connected to a worm gear and worm wheel. The worm wheel is a part of the output shaft and provides multi-turn motion. The output of a multi-turn actuator is torque, measured in foot-pounds, inch-pounds, or newton-meters, and also speed, which is measured in rotations per minute. The second type of valve stroke is quarter-turn. In this case, the motor and worm are similar to the multi-turn example, but the worm wheel may have quarter-turn stops restricting the range of travel, or may have only a quarter of the teeth on that worm wheel populated. The output here, again, is torque and speed, but speed is typically measured in seconds per 90 degrees of travel. The third type of valve stroke is linear. The motor and worm are again connected here, but the worm wheel has interior female threads which cause an attached linear adapter to move in an extended or retracted manner without rotating. These linear adapters are used for valves whose stems would otherwise rotate without moving in or out. For valves with threaded stems that are fixed and do not rotate, the valve can be connected directly to the threaded drive at the base of the actuator. We hope this video was helpful in providing an overview of how electric actuators create multi-turn, quarter-turn, and linear motion. Please join us on the next video to learn about how electric actuators cover a range of valve sizes.